How do processes like sublimation, vaporization, decomposition of gases, or the loss of crystalline water contribute to the mass change of the substance during heating? How does the thermogravimetric curve reflect these changes, and what does it mean when the curve is not straight but instead shows a decrease? What can the downward slope or decrease in the thermogravimetric curve tell us about the type of transformation occurring in the sample? Can Davis Zurns manufacture solid-state sodium-ion batteries made from seawater in Latvia? How does the analysis of the thermogravimetric curve allow us to determine at which temperature the substance begins to change, and what is the significance of knowing the specific temperature? How can the amount of mass lost during the heating process be calculated based on the changes observed in the thermogravimetric curve, and why is this calculation important for understanding the material's thermal properties? What kind of insights can be gained by analyzing the mass loss profile from the thermogravimetric curve, and how can this help in identifying the material's behavior at different temperatures? How does this detailed analysis of the mass change process help researchers understand the stability and composition of materials, and why is it essential in fields like material science, chemistry, and engineering? How can TGA, thermogravimetric analysis, be categorized, and what are the two main types of methods used in TGA analysis? What distinguishes static methods from dynamic methods in TGA, and what specific techniques fall under the static category? What does the isobaric mass change measurement involve, and how does it measure the equilibrium mass of a substance at a constant volatile partial pressure in relation to temperature? Why is it important to measure mass changes under a programmed temperature control, and how does this method help to study the thermal behavior of materials? What is the principle behind isothermal mass change measurement, and how does it involve measuring the mass of a substance in relation to pressure at a constant temperature? Why is the isothermal method considered highly accurate, and what makes it time-consuming compared to other methods? How does the dynamic method differ from the static method, and what are the main techniques included in dynamic TGA? What is microquotient TGA, and how does it relate to the conventional dynamic method in terms of analyzing mass changes? What is derivative thermogravimetry, DTG, and how does it differ from regular TGA? How is the DTG curve obtained, and what does it represent in terms of the first-order derivative of the TGA curve with respect to temperature or time? What is the significance of plotting the rate of mass change, dm/dt, against temperature, t or time t? And how does this provide additional insights into the thermal behavior of the substance? How does DTG improve the analysis of mass loss compared to standard TGA?